We're going through interview questions for the Go programming language. These are questions that if you're a dev and you're applying for a job as a Go developer, you might be asked these questions. And if you're an organization that wants to hire Go developers, have you seen my resume? If you're an organization that, actually I'm transitioning from academia into private industry, so totally open to all inquiries. But here we go. If you're an organization that wants to interview Go developers, you could use these questions. And these questions can be found, all these questions I've developed, here at Goes to 11 on GitHub, the Learn to Code Go version 3, my dog's saying hello, repo. And then you scroll on down, the zeros are just like my work area, and then anything with numbers are, it's code for this course, which you can find right here, Udemy Todd McLeod, the Go programming language if you want to upskill. My dog is really going for it. And I'm going to pause here in a second, but I want to show this to you. But this right here is where all the questions are. That's where it's at. Hold on one second. All right, hopefully my dog's chilled out. All right, so for this question here, the question that we're going to look at is what types can a map use as a key in the Go programming language? And this could either be an intermediate or an advanced question. It certainly just speaks to the mechanics of the language, but also the way you answer it can determine whether or not you fall into the intermediate or advanced category. And so I'm categorizing all these as we go through them. And the answer for this question is any type that is comparable, right, could be used as a key. So that's like the mechanics, that's the intermediate. That's the intermediate answer, and we're going to explore that here in a second. But the advanced answer here is to start talking about generics. And so if you talk about generics, you could talk about the new type, which is comparable, and how when you're using generics, you could use that type comparable. And so you could discuss those aspects. But let's look at just the main comparable types, which are able to be used as a key. Because remember, you're going to check if, like, you know, the key is an int and you're looking for ID 42, you're going to check the maps key for 42 and the map will see, hey, is there a comparison? So you need things which are comparable. So that's how maps work. So here I just brought up a few resources about comparable. So here if we look at the language spec, actually I put these into a note somewhere in here. Maybe I put it down at the bottom because I wanted to be able to go through it pretty quickly. Hang on one second, let me find it. All right, here we go. I found the note, and these notes are from the language specification, and then also the notes are from Effective Go, my two favorite sources, and I have something to share with you about that from the Go blog here in a moment. But here we see map types. A map is an unordered group of elements of one type called the element type. That's interesting, right? And indexed by a set of unique keys of another type called the key type. So down here, they also refer to the element or the value. So we have basically a key and a value, and the value could also be referred to as an element. The value of an uninitialized map is nil. The comparison operators equals, double equals, and what do they call that? Bang equal? Not equal must be fully defined for operands of the key type. Thus, the key type must not be a function, map, or slice, so it can't be a function, map, or slice. If the key type is an interface type, these comparison operators must be defined for the dynamic key values. Failure will cause runtime panic. So I put the important parts in capitalization here. And maps are a convenient and powerful built-in data structure that associate values of one type, the key, with values of another type, the element or value. The key can be of any type for which the equality operator is defined, such as integers, floating point and complex numbers, strings, pointers, and interfaces, as long as the dynamic type supports equality, structs, and arrays. Slices cannot be used as map keys because equality is not defined on them. So that's the answer for this question, is you need things which are comparable. And you could see that here, what I just referenced in the language specification. So you could pause the video and take a look at that. And you can also see it here in Effective Go. So you could pause the video and take a look at that. And you can also see the comparison operators here again, and some notes on comparison here in the language specification once again. So you could take a look at that. And notice the word comparable here is being used all the time. And then we also have this new type here at the language specification. And this new type is comparable. And that comparable type can be used with generics. And so if you go to Golang blog, just for advanced reading, and you search for generics, I'm going to actually search for comparable just to narrow the results, and all your comparable types. Here we go. And when you scroll down through here, this is my favorite sentence in this blog post. This is my favorite sentences in this blog post. Disputes are resolved by consulting the spec, not by decree. I like that sentence. So that's a little bit about comparable and in relation to generics, and then also the answer for this question: what types can a map use as a key in the Go programming language? They could use any types for which the comparison operators can work, right? And so those types include integers, floating point, complex, strings, pointers, interfaces, structs, and arrays, but not slices, right? And yeah, so those are the points. All right, that's my answer for this question.